Hello everyone and welcome to Data Science Floor. My name is Yasham Rashid and I will be teaching this data science course. This is the introduction class where I will discuss the details of the data science course, and I will go through all the topics and the tools which we are going to cover in this course. So here is an introduction about myself. I did my PhD in computer science from George Mason University, and my research topics include data mining and machine learning algorithms. And after I finished my PhD, I have been working in the industry as a data scientist. And my former company name is Resonate Networks. At Resonate, I worked on the browser history data and the survey data to predict the user's activity and show them the right advertisement based on their interest. My current company, MapQuest, which is owned by AOL, at AOL I am working on a location-based analytics, which use third-party data as well as geolocation data to target people. And now this targeting is based on their locations as well as their interest. So to summarize all this stuff in one line, basically I am doing predictive modeling and analysis on the available data. I've been involved in the teaching as well, so I am working as an adjunct faculty at George Mason University and East Air University, where I am teaching computer science courses in the undergrad and grad level. So let's see what Harvard Business School thinks about data scientist role. So in one of their articles, they claim that the data scientist job is the most demanding job of the 21st century. So what do you think? Like, what is the reason behind this statement? This is all because of the large volume of data which is available today, and because when it comes to the data, it brings both an opportunity and a challenge for the organizations, and it makes you think about like how to store the data or how to transfer the data and how to analyze the data. So as I said earlier, we are producing a lot of data these days. Just look at these companies and the data they are producing every day. For example, Twitter is producing 500 million tweets per day. Facebook, which has 955 million users, they are producing 3.2 billion likes and comments every day. Also YouTube, they have like more than 1 billion unique visitors each month. And Amazon, it has 26.5 million transactions per day. So apart from the size of the data, you can also see that the data is of different types. For example, the Twitter and Facebook data, they are used to analyze social activity of users. And if you look at the YouTube and Google, the data can be used for search, and you can also look at the browsing habits of the users. And if you look at the Amazon data, you can analyze this data as a transaction data and look at the transactions of the users and their purchasing activity and behavior. So after looking at the trend of producing large amount of data by these companies, the McKinsey Global Institute wrote an article where they estimated that by 2018, the United States alone could face a shortage of 140,000 to 190,000 people with deep analytical skills, as well as 1.5 million managers and analysts who have the skills to analyze the data and to make effective decisions out of it. So if you look at the data, so the data scientist's role have the technical and analytical skills to drive meaningful information from the data, and that's the reason they are in high demand these days. Also, one of the problem I see is the choice of tool for data analysis. I have talked to many people who are working in the field of data analysis, and they claim that Excel is enough for their analysis. What I would say is that it's time to make new friends, because by using Excel only, you are definitely missing a lot of opportunity in data analysis. Also, many tools are available especially designed for data analysis. For example, R, which is an open source tool, and it provides more powerful data processing capabilities. I will discuss R tool in detail, and also I'll compare Excel with R later in this session. Now the new tech industry, which is driven by big data, it requires three kind of roles. So the first role, which is called deep analytical talent, It contains people who have a very strong technical background, and they have the skills to handle different kind of data, for example raw data and unstructured data, and they also have a command on the complex analytical machine learning techniques. And the example of the professions in this role are data scientists, statisticians, and economists and mathematicians. So the second role is called data savvy professionals, and they are the peoples with a basic knowledge of statistics. And the example of these professions are financial analyst, market research analyst, operations managers, business and functional managers. And the third role in this industry is called technology and data enablers, and basically they are the people who provide support and technical expertise to different projects. And the examples of these professions are computer programmers, database administrators, and computer system analysts. So, if you ask me about the data scientist key activities, I would say data scientist acquires a combination of skill sets. So, rather than having a separate people for discovery phase of a project, or a different person to deal with the business goals, or another person with the technical expertise and quantitative expertise, the data scientist basically is a combination of these aspects, and they provide help throughout the process. As you can see in this slide, the data scientists can create insights and give recommendations, and they can actually transform business challenges into analytics challenges, and they design and implement the actual models and data mining techniques to process the data. So this is how the data scientist profile should look like. Here we have 5 characteristics. The first one is called quantitative, which means that the data scientist must have the basic knowledge of mathematics and statistics. The second one is called technical, which is more related to the skill set. So it means that the data scientist must have the programming skills and the basic problem solving skills. The third one is called skeptical, which is very unique, and this is the one which I like the most. So it means that it is very important for data scientists that they should not be biased towards their analysis, and they should always examine their work critically rather than in a one-sided way. The fourth one is called curious and creative, and which tells us that the data scientists must be passionate about data, and they should always try to find creative ways to solve problems and portray information. The fifth one and the last one is called communicative and collaborative, and this characteristic tells us that it is not enough to have strong quantitative skills or engineering skills, but to make a project successful and resonate, you must be able to articulate the business values in a very clear way, and to work with project sponsors and key stakeholders in a very productive way. So after learning all the different aspects of data science, and by looking at the magnitude of the data produced by the big companies, and also different types of data which is available today, now it's time to explore all the possibilities of becoming a data scientist. And one way to achieve this goal is to learn about data science and get some hands-on experience in this field. And this course is designed to achieve such goals for the people who have a very little or even no experience in the data science. In this section, I will explain the structure of this course, and then I'll talk about the different modules in this course, and also I will talk about the distribution of topics for each week. Here is the complete schedule of a data science course, and I will complete this course in 8 weeks. And apart from the weekly lecture, every week has its own homework assignment. So in week 1, we will be learning how to write code in R programming language, and basically how to use R tool. In the second week, we will learn another language which is called structured query language, also known as SQL, and this language is used to access the database. From week 3 to week 7, we will learn about data mining and machine learning algorithms and how to write them in R programming language. And in week 8, we will learn about 2 frameworks called Hadoop and MapReduce, which are used for big data analytics. So let's talk about every module in detail. So the first thing we will do in this course is to get familiar with the R environment, because we will use R extensively in this course. So we will learn about how to invoke the R environment, and how to write important R commands, and also how to load and read data sets. And once you read the data set in the R, how can you perform the summary statistics on those data sets. And good visualization is very important for presenting your analysis. It's a famous saying that a picture is worth 1,000 words. So it exactly fits here, as you can present your complex analysis by using very simple and very well designed graphs and plots. In week 2, we will learn SQL, which stands for Structured Querying Language. And if you want to define SQL, you can say that this language is used to extract or get the data from the database table. So in this course, we will use SQL to get the subset of the data from large database tables, and then perform the analysis on the subset of the data. Data scientists must learn SQL so that they can extract the right data for their analysis. Week 3 to 7 are the most intensive weeks in this course. Since at this point we already know how to use R and SQL, we are ready to learn data mining and machine learning algorithms. I will explain the algorithms and the technical foundations so that you would be able to answer for any particular algorithm that what is this algorithm and why we use this algorithm. I also explain the use case for each algorithm so that you would be able to answer that on what circumstances and on what situations we should use this algorithm. And I will also go through some of the methods to validate the results of the algorithm. Now let's talk about the different kinds of problem we see in the field of data analysis, and the type of the techniques which is used to solve those problems, and also the actual implementation of the algorithm for this technique. So the first technique is called clustering, and clustering is used when you want to find the structure in the data, or you want to find similar group in the data. To give you a real world example of clustering, in my last company I was working on a project called Voters Landscape, and the goal is to analyze the elections data and some survey data across the United States and to find different kind of groups in that data set. When I performed clustering on that data set, I found very interesting groups. For example, one group was supporting coal energy, one of the group supports clean energy, and one of the group was supporting gun control, and there are some groups which supports or which are more likely to buy organic foods. Then my company used those analysis and results to educate the political party candidates that if you wanted to win election in that state, then you have to talk about gun control, or if you wanted to win election in that state, then you have to talk about the interest of the people who supports coal energy or who supports clean energy. Now you understand how clustering is used in the data analysis. The second technique is called association rules, and we use that technique when we want to discover relationships between actions or items. And most of the time the problem deals with the transaction data. And the real world example of such kind of problem is to analyze the Amazon transaction data. When you look at the Amazon data, you see the buying and selling behavior of the customers, and when you apply association rule algorithm on that data, you are trying to find some interesting rules in it. For example, you may find a rule where people who buy printer are more likely to buy printer papers as well, or the people who are buying soda are more likely to buy snack food, and so on. So by using these interesting rules, you can actually recommend different kinds of product to each customer at the time of their purchase. So another type of technique is called regression, and you use regression when you want to find out the relationship between the outcome and the input. And to give you a real world example, you can think of if you are working in a credit card company and you wanted to find out the relationship between the credit score and some other factors. For example, what is the effect of number of children on the credit score, or what is the effect of income on the credit score. And using regression, basically you can create a very good credit card approval system based on different factors. The last type of technique which we are going to cover in this course is called classification, and you use classification when you want to assign a specific label or a class to the objects. For example, given an email, can you classify if the email is spam or not? Or by looking at the loan application data, can you classify if the loan is going to be approved or not? And if you look at the real world example, you can look at the Twitter data and ask the question that if the comment is neutral or a positive or a negative comment. So at this point you understand how each type of technique is used to solve a particular type of problem. So if you look at the third column, these are the names of the algorithms for each type of technique. For example, k-means clustering is used to perform clustering, a priori algorithm is used to perform association rules, linear and logistic regressions are used to perform regression, and naive Bayes and decision trees are used to perform classification. So at this point you may ask this question that why are we only studying these algorithms although there are many other algorithms available? So the answer to that question is that these are the most popular and frequently used algorithms, and they provide the foundation for the data science skills. And also they are very easy to understand, especially if you are new to this data science field. And most important, these algorithms can solve a broad range of problems. And being a data scientist in the industry, I use these algorithms extensively in my daily tasks. Let's have a look at the topics for week 8. In week 8, we will cover big data analytics and focuses on two major frameworks, especially designed to handle big data. Hadoop is a framework which is designed to store and access large volume of data, and we will learn some basic Hadoop commands as well. And MapReduce is a programming model that is used to distribute tasks on several machines for a faster processing. For the hands-on experience and the practical training, I will provide you the pre-installed virtual machine, and this virtual machine will give you the exact same environment as seen by the data scientist in the industry. This machine also contains all different kinds of data sets which we will use in our data analysis. In this machine you will find R Studio and R Studio Server, PostgreSQL database, and Hadoop environment already installed. For this demo class, you can also install R and RStudio on your local machine.